Welcome friends to my channel. Today I will be discussing the subject strength of materials MCQ question from Khurmian Bukta book, question number 201 to 250. So let's start. Question number 201. When a beam is subjected to a bending moment, the strain in a layer is option B directly proportional to the distance from the neutral axis. Next question 202. The bending moment equation is option A is the right answer. M by I equal to sigma by Y equal to E by R. E is the Young modulus of the material of the beam. R is the radius of curvature of the beam. M is the bending moment of the beam. I is the moment of inertia of the section of beam. Sigma is the bending stress of that beam, and Y is the distance from the neutral axis to the extreme fiber of the section. Next question 203. A section of beam is said to be in pure bending if it is subjected to option C is the correct answer, constant bending moment and zero shear force. Next question 204. When a beam is subjected to bending moment, the stress at any point is option B is the right answer, directly proportional to the distance of the point from the neutral axis. Next question 205. The line of intersection of the neutral layer with any normal cross section of the beam is called neutral axis. Option A is the right answer, true. Next question 206. The neutral axis of the cross section of a beam is that axis at which the bending stress is. Option A is the right answer, 0. Next question is 207. The neutral axis of the symmetrical beam does not pass through the centroid of the beam. Option B is the right answer, because in case of symmetrical beam, the neutral axis always pass through the centroid of the beam. Next question 208. The section modulus Z of a beam is given by. Option A is the right answer, I by Y. I is the moment of inertia of the beam section and Y is the distance between neutral axis of the beam section and the extreme fiber. Next question 209. The section modulus of a rectangular section about an axis through its CG is. This is a rectangular section, breadth B and depth D. This is the center point or centroid of the section. So we know the moment of inertia I will be BD cube by 12 and Y, which is the distance between CG of the section and the extreme fiber, which is D by 2, and Z is equal to I by Y, we know, so which will be equal to BD square by 6. So for question number 209, option D is the right answer. Next question 210. The bending stress in a beam is, option B is the correct answer, inversely proportional to the section modulus. We know M by I equal to sigma by Y. Sigma is the bending stress, Y is the distance between CG of the section and extreme fiber of the section, M is the bending moment, and I is the moment of inertia. So from here we will get sigma equal to M into Y by I, and Y by I we know is the 1 by section modulus. So we can write sigma equal to M by Z, and sigma varies as 1 by Z. We can say the bending stress in a beam is inversely proportional to the section modulus Z. Next question 211. The section modulus of a circular section about an axis passing through its CG is. This is a circular section. This is the centroid of the section G. So we know the moment of inertia of the circular section pi d to the power 4 by 64, and Y is the distance between centroid of the section and the extreme fiber, which is D by 2, and D is the diameter of this circle. So Z will be equal to I by Y. If we calculate, Z will be equal to pi d cube by 32. So for question number 211, option D is the right answer. Next question 212. If the section modulus of a beam is increased, the bending stress in the beam will, option C is the right answer, decrease, because we know section modulus is inversely proportional to bending stress. So if section modulus is increased, bending stress will automatically decrease. Next question is 213. For a given stress, the ratio of moment of resistance of a beam of square cross section when placed with its two sides horizontal to the moment of resistance with its diagonal horizontal is. This is the square section of side A. So the moment of inertia of this square section will be a to the power 4 by 12, and y, the distance between CG of this section and the extreme fiber, will be y equal to a by 2, and the section modulus of this section z will be equal to I by y, and it is z1 will be equal to a cube by 6. Next case, the square cross section placed with its diagonal horizontal. So in this case, the moment of inertia will be the same, a to the power 4 by 12, but the y distance will be a root 2 by 2, which will be also equal to a by root 2. So section modulus for this case, z2 will be a to the power 4 by 12 into root 2 by a, because z2 will be equal to I by y, and if we calculate, the value will be a cube by 6 root 2. Now if we make the ratio of z1 by z2, the ratio will be root 2. So for question number 213, option number D is the right answer. Next question 214. A square beam and circular beam have the same length, same allowable stress, and the same bending moment. The ratio of weights of the square beam to the circular beam is, as the both beams have same allowable stress and same bending moment, the weight of them will be proportional to their cross-sectional area. So their section modulus will be equal. So section modulus of this square section will be a cube by 6, and section modulus of the circular section ZC will be pi d cube by 32, and we know ZS will be equal to ZC. So if we calculate the value, we will get small d equal to 1.193 A. Now if we make the ratio W1 by W2, which will be also equal to A1 by A2, cross sectional area equal to A1 will be the area of the square A square, and A2 will be the area of the circle pi d square by 4, and we got the value of small d equal to 1.193 A. So if we put the value of small d equal to 1.193 A in this area, so we will get the ratio 1 by 1.12. So for the question number 214, option number C is the right answer, 1 by 1.2. Next question 215. Two beams, one of circular cross section and other of square cross section, have equal area of cross section. When these beams are subjected to bending, option B is the right answer. Square beam is more economical because the area of square cross section will be less as compared to circular cross section. Next question 216. In a beam of uniform strength, the bending stress developed is constant and is equal to the allowable stress at every section of the beam. Option A is the right answer, true. Next question 217. When a cantilever beam is loaded at its free end, the maximum compressive stress shall develop at, option A is the right answer, bottom fiber, because in case of cantilever beam, the compressive stress is generated at the bottom fiber and tensile stress is generated at the top fiber. Next question 218. A beam of uniform strength may be obtained by, option A, keeping the width uniform and varying the width, right? Option B, keeping the depth uniform and varying the width, right? Option C, varying the width and depth both, right? Option D, any of the above. Option D is the right answer. By doing all this, a beam of uniform strength may be obtained. Next question 219. If the depth is kept constant for a beam of uniform strength, then its width will vary in proportional to, suppose this is the cross section of a beam, breadth B and depth D. So we know bending moment M will be equal to sigma into Z. Sigma is the bending stress and Z is the section modulus. So M will also be equal to sigma into value of Z, which is BD square by 6, because it is a rectangular section, and from this calculation we can write small b equal to 6m by sigma d square. So we can say the width B is proportional to bending moment M. So for question number 219, option A is the right answer. Next question 220. A beam of uniform strength has Option B is the right answer. Same bending stress at every section. Next question 221. The bending stress in a beam is, option D is the right answer, directly proportional to the bending moment. Next question 222. At the neutral axis of a beam, option D is the right answer. The layer do not undergo any strain. Next question 223. The neutral axis of a beam is subjected to, option A is the right answer, zero stress, because at the neutral axis there will be no stress at all. Next question 224. The neutral axis of a transverse section of a beam passes through the center of gravity of the section and is, option D is the right answer, at right angle to the plane in which the beam bends. Next question 225. On one side of a neutral axis of a beam there is a tensile stress and on the other side of the beam there is a compressive stress. Option A is the right answer. Agree. Next question 226. In a beam subjected to pure bending, the intensity of stress in any fiber is, option D is the right answer, directly proportional to the distance of the fiber from the neutral axis. Next question 227. The rectangular beam A has length L, width B and depth D. Another beam B has the same length and width but depth is double that of A. The elastic strength of the beam B will be how much as compared to beam A? So let's see. Friends, we calculate the elastic strength of the beam by the section modulus of the beam. So this is a rectangular beam section, breadth B and depth D. This is the neutral axis. So mathematically we know section modulus Z will be equal to I by Y equal to BD square by 6. We can also write Z varies as small d square. So section modulus will vary with depth with square of the depth of the beam. We know the depth of beam B will be double of A. So D capital B will be equal to 2 into small d capital A. And if we make the ratio of section modulus ZB divided by section modulus ZA, so we will get small dB by small dA whole square, and we know dB equal to 2 dA. So if we put the value, we will get ZB equal to 4 into ZA. So for question number 227, the elastic strength of the beam B will be 4 times as compared to the beam A. Next question 228. The rectangular beam A has length L, width B and depth D. Another beam B has the same length and depth but width is double of that A. The elastic strength of the beam B will be how much as compared to the beam A? We know from this equation section modulus will be directly proportional to the breadth of the beam small b. So we can write Z varies as B. So if we make the ratio ZB by ZA, so we will get small breadth B of the beam B divided by breadth B of the beam A. So if we calculate the value, we will get the value equal to 2. So for question number 228, option number B is the right answer. The elastic strength of the beam B will be double as compared to the beam A. Next question 229. The rectangular beam A has the length L, width B and depth D. Another beam capital B has the same width and depth but length is double of that A. The elastic strength of the beam B will be how much as compared to the beam A? Friends, we calculate the elastic strength of the beam by the section modulus of the beam. So the section modulus of the beam does not depend on the length of the beam. So the elastic strength of the beam B will be same as compared to the beam A. Option A is the right answer for question number 229. Next question 230. When a rectangular beam is loaded transversely, maximum tensile stress is developed on the, option B is the right answer, bottom layer, and at the top layer above the neutral axis it is compressive stress which is developed. Next question 231. When a rectangular beam is loaded transversely, the maximum compressive stress is developed on the, option B is the right answer, bottom layer. Next question 232. When a rectangular beam is loaded transversely, the zero stress is developed on the neutral axis. Option A is the right answer. Next question 233. When a rectangular beam is loaded longitudinally, the shear force develops on the top layer. No, when a rectangular beam is loaded longitudinally, the shear force develops on every horizontal plane. The shear stress diagram is parabolic for a rectangular beam. Next question 234. At the neutral axis of a beam, the shear stress is, option C is the right answer, maximum. Next question 235. The maximum shear stress developed in a beam of a rectangular cross section is, option C is the right answer, 1.5 times the average shear stress. Next question 236. The maximum shear stress developed in a beam of circular section is, option B is the right answer, 4/3 times the average shear stress. Next question 237. The ratio of maximum shear stress developed in a rectangular beam and circular beam of the same cross-sectional area is, we know the maximum shear stress for rectangular section is 1.5 times the average shear stress, and maximum shear stress for circular cross section is 4/3 times of the average shear stress. If we make the ratio, we will get the value 9/8. So for this question 237, option D is the right answer. Next question 238. A beam of triangular section is placed with its base horizontal. The maximum shear stress occurs at, option B is the right answer, mid of the height. Let me show you the diagram for the triangle. This is the triangle. So in this diagram you can see the maximum shear stress will occur at the mid height of the triangle. So for question number 238, option B is the right answer. Next question 239. The maximum shear stress of a beam of triangular section occurs above the neutral axis. Option A is the right answer, correct. This is the triangle and this is the centroid of the triangular section. So here the neutral axis will pass and the maximum shear stress is always above the neutral axis, tau max. So for this question 239, option A is the correct answer. Next question 240. A beam of T section is subjected to a shear force of F. The maximum shear force will occur at the, option C is the correct answer, neutral axis of the section. This is the T section, you can see from this diagram. This is the neutral axis of the T section. So maximum shear stress will occur at this neutral axis of the T section. Next question 241. Which of the following statement is wrong? Option A. In the theory of simple bending, the assumption is that the plane section before bending remains plane after bending. Right. Option B. In a beam subjected to bending moment, the strain is directly proportional to the distance from the neutral axis. Right. Option C. At the neutral axis of a beam, the bending stress is maximum. Wrong. Option D. The bending stress in a beam is inversely proportional to the section modulus. No, it is right. So option C is the right answer for this question. Next question 242. A flexed beam is used to, option C is the right answer, equalize the strength in tension as well as in compression. Flexed beam is the beam where steel plate is sandwiched between two wooden beams and connected with bolts. It is lighter and cheaper than the pure steel. Next question 243. A rectangular beam of length L supported at its two ends carries a central point load W. The maximum deflection occurs, option B is the right answer, at the center. This is a simple supported rectangular beam. The central point load P at the center. So maximum deflection will be at the center and it will be equal to PL cube divided by 48 EI. Next question 244. A simply supported beam of length L carries a point load W at a point C as shown in the figure 2.45. The maximum deflection lies at, I have drawn the figure. The simply supported beam AB, the point load W at a distance A from this end, and this distance from load to this end is B. So the maximum deflection will occur between B and C, and it will be equal to YC equal to WAB by 6 EI into L within bracket L square minus A square minus B square. So for question number 244, option D is the right answer. Next question 245. For a beam as shown in the figure 2.45, the maximum deflection is W A square B square by 3 into E I L. Option B is the right answer. False, because we calculated the maximum deflection will be WAB divided by 6EIL within bracket L square minus A square minus B square. Next question 246. For a beam as shown in the figure 2.45, the deflection at C is. So friends, in this beam, simply supported beam, point load acting at a distance small a from this end and at a distance small b from this end. The deflection at this point C will be, which is maximum deflection, Y max will be equal to WA divided by 9 root 3 EIL within bracket L square minus A square to the power 3 by 2. So for this question 246, option C is the right answer, and this is not A, this will be 9 and it is a print mistake. Next question 247. For a beam as shown in the figure 2.45, the maximum deflection lies at. We calculated the maximum deflection will occur at a distance x from this end B. So x is equal to root over of L square minus A square divided by 3. So for question number 247, option C is the right answer, root over of L square minus A square by 3 from B. Next question 248. For a beam as shown in the figure 2.45, when the load W is applied in the center of the beam, the maximum deflection is. In this beam, when the point load is applied at the center, so the deflection will be WLQ by 48 EI. So for question number 248, option A is the right answer, WLQ divided by 48 EI. Next question 249. A simply supported beam of length L is loaded with a uniformly distributed load W per unit length. The maximum deflection is 5 WL to the power 4 by 384 EI and lies at the center of the beam. As per the question, simply supported beam AB subjected to uniformly distributed load, the maximum deflection will be at the center and it will be equal to Y max equal to 5 WL to the power 4 divided by 384 EI. Question number 249, option A will be the right answer, true. Next question 250. The simply supported beam A of length L carries a central point load W. Another beam B is loaded with a uniformly distributed load such that total load on the beam is W. The ratio of maximum deflection between beam A and B is. In the case 1, for beam A, the simply supported beam loaded with a central point load W. The maximum deflection Y max will be WLQ divided by 48 EI. And in the second case, for beam B, the simply supported beam subjected to uniformly distributed load W per meter, which is also equal to total load W. The maximum deflection will also be at the center and it will be equal to 5 WLQ divided by 384 EI. And if we make the ratio deflection Y max A divided by deflection Y max B, we will get the ratio 8 by 5. So for question number 250, option B is the right answer. So friends, I will be back in the next video in quick time. Please keep supporting me and help me to go ahead. And if you have any doubts about the solution, please let me know in the comment section. Thank you.